Thank you all so much for joining us today to talk about freeform injection molding. My name is Louis Sims, and I am the head of industrial product marketing for Nexa 3D. Joining us today is Karsten, who is our head of business development and the sales manager for freeform injection molding in the Americas. Say hi, Karsten.
Hi all, looking forward to meet you.
So for today's agenda, we're going to cover a few things to make sure that you're very familiar with freeform injection molding. So we'll talk about what is freeform injection molding, why is this relevant to you, how can this help your business, what specific things are involved in freeform injection molding, talking about the entire workflow from beginning to end. And then we'll also cover who's using freeform injection molding today. So it's great to hear about this incredible material and process and workflow, but it always helps to see how people are using it in the real world. And so we'll be sure to talk about that as well. And then lastly, how do you get started and what are your options if you're interested in pursuing this further? And then we'll open it up for Q&A where we'll try to answer as many questions that we can. So if you're new to Nexa 3D, just wanted to tell you a little bit about us. We were founded in 2016. We currently have a little over 85 employees, and we're headquartered in Ventura, California. So this is not only where we house our engineering staff and all of that fun stuff, but we do our manufacturing there as well. So that's where all of our printers are built, and our resin is assembled and all of that too. So that's always a common question. In addition to that, we work with additional material partners. We are an open platform, so you don't just have to use Nexa resins. And we are partnered with over 100 resellers across the globe that can help support Nexa products, our materials, and your applications. And of course, what aligns all of us, the reason why we show up to work every day at Nexa 3D, is because we have a common mission, and that is to digitize supply chains sustainably. And I think the conversation today around leveraging freeform injection molding to do that is a really compelling one. And so we'll let Karsten dive further into that. And with that, I'll let Karsten introduce himself. He knows himself better than anyone. So Karsten, I will let you take it away. Thank you so much.
Thanks, Louis, and welcome all to this webinar. It's let it be no secret, we've been looking forward to hosting this and sharing what we're all passionate about and kind of give you the insights of what we have seen over the years with freeform injection molding. I've been in the space of freeform injection molding for almost 5 years now. And I think what I'm going to share today on behalf of the whole team is kind of that obsession, passion, curiosity, exploration that allows yourself to do some of the things that we are sharing here today. And I think most of what you will see is actually just from the inside of projects and processes. And it's going to be driven by the quite many projects we have done in various industries over the last many years. And then it's going to be footage, videos, close-up things of non-post-processed parts. So what you're seeing, there's one photo in the whole webinar that is post-processed. The rest is how things look straight out of a printed tool, just to let you know. Okay, so now we're all comfortable in front of our screens somewhere in the country, in the world, in the States around. But I think what we just as some introduction work to what is freeform injection molding all about. I think if you could just allow yourself to spend the next 40-45 minutes of kind of forgetting a little bit about what you normally do, how you're constrained in this or that way. And kind of assume a few things together with us here. Then it will make the bandwidth, hopefully, a quick download from what we've seen and what we are doing and have done to how could you do this if at all possible and if at all in your interest. So think of it like this. If you could work with any design, and I'm thinking also about the organic, crazy designs of parts, and you can work in any material, including your regulatory ones, your final parts materials, and all those things. And if you could then be injection molding as you go along, I mean, in real time, as you develop on the day, on the week, on the month, what would that enable you to do, or what would that actually inspire you to do in terms of what could you then make, what would you learn, what would you not do, what would you not launch, what would you rework, change, and what would you actually maybe fast forward to the markets that you're addressing with your industry relevant parts and projects. I think that's a lot of freedom right there, and I think it's needed in order to, to take in just a photo like this. I mean, if I only had one slide to show with visuals, it would probably be something like this, where you see a lot of different shapes, parts, materials, combination of materials. You see some processes involving overmolding, insert molding, fiber filled, glass filled, and in general, you just see a lot of freedom to choose and freedom to iterate in your development process. It also, freeform injection molding, as you will stumble into during the presentation, named as FIM or FIM, also caters for the whole injection molding feedstock, including powder, metal powder, ceramics, so MIM and SIM, and everything from soft to hard. So it's a lot of things we have to cover, and I will make sure that we will get there, so there will be room for Q&A, and please use the various channels to feed your questions and curiosity to us, so we can get to answer them, hopefully. So why are clients of ours and prospects and curious window shoppers, why are they interested in something like freeform injection molding? Quite many reasons why. We tried to summarize a few of the major categories of why, and the first one is not unknown to most of us. It's called impatience and getting somewhere faster, preferably by yesterday. And I think that's not different when you use freeform injection molding. What might be different with freeform injection molding as a source of validation, as a source of development and iteration, is that you can change some of those things. In the past, you could say, there was always a design freeze. At some point, someone cut a check to cut a tool to do some molding down the road, and no one better not have a good idea the day after that process was done, because someone froze the project and moved on. With freeform injection molding, that is a daily happening. It's a unfreeze and freeze as you will. It doesn't have to be a pre-planned event to freeze a project to do the heavy investment, because the heavy investment is not really there. Then it can be, time to revenue, time to scale, but there's always some urgency, which is good. And then there's this degree of freedom with design material we just covered. And I think the ability to work with the materials of choice and the materials that you either have a regulatory limited working space around, that's a relief, because you can work with them from the first day, the first design iteration. Then in general, it's about bringing down investments and taking down the risks of those investments. What do you know on the day when you invest versus what do you know on the day that you did the first part and you look at what comes out? Those are two different timelines or two different places on the same timeline, but it's definitely also two different cost allocations right there. So you could say freeform injection molding as a technology. I would rather call it's a tool design and mold manufacturing access on demand, when you need it, if you need it, where you need it. And it's all grounded in very good printers. We offer all the printers you want here on the resin side, and with the xMOLD resin that we'll dig into a lot more in the later slide, we will get you going. So just to frame the space of what is printing, what is freeform injection molding, what is injection molding. If you look to the left on this visual here, there's a traditional product development cycle, and then there's a market product development cycle. And at the left side here, you see you've always been prototyping using, or mostly have been using certain technologies for prototyping. And then once they saw what worked and did not work, let's get serious and move on to injection molding, because we need scale, we need surface quality, we need volume, we need quality, so to say, at scale. With freeform injection molding on FIM, you kind of just bridge that gap. No one tells you to be working on left side or right side. Imagine this, that you have one of the Nexa printers here, and we one day print parts on the printer in the qualified resins to print direct parts with, and another day you pour in the freeform injection molding enabling resin called xMOLD, which is just another resin running on the printers. And with that one, you're now printing tools for injection molding parts. Same printer, same technology, two different agendas, two different options on that day. The big difference, as we already covered briefly, is one is direct printed materials, is whatever it is of range, 20, 30 ones. And with injection molding feedstock that you can use in the printed tools, you're now opening up to a gallery of thousands, hundreds of thousands, depending on how you calculate that. That's what we call a lot of options right there. On the right side here, it's also giving you a lot of business options. That could be, are you looking at doing low volume, high mix products? Are you trying to design in new materials, new designs, see functionality tests early on, validate them for scaling? Or are you handling someone's spare part management program where they have a long legacy and a long obligation to supply parts in certain materials using certain processes? Those are now things you call the shots on, and no one can tell you where to be on that line, but you have the opportunity and ability to walk up and down those lines of product development and business spaces. And speaking about risks versus what do you know, what do you not know on when do you move forward with your product development and your next investment, this one is a way of saying, how does AM, additive manufacturing, lead to how do you have a smooth transition to injection molding IM on this one? And currently, if you look at the visual right now, there's a bit of a gap there where you know something and then you hope for the rest and you convince your CFO about that you know how to cover that gap. With freeform injection molding, you can work and validate your way through from AM over FIM to IM. A lot of M's right there, but from additive manufacturing to freeform injection molding, which is additive manufacturing of tools, and then to injection molding of parts, which is actually where most want to end up. We just make the journey more seamless and more data-driven. You can have many good reasons to want to have freeform injection molding or not. One of the strongholds that we see is speed and cost. Time and cost. I know time is also cost, but people often categorize it like this. So this is a study done by Deloitte on 5 medical device development projects using freeform injection molding versus using traditional metal prototype tooling. And the left side shows the conventional cost picture or impact picture, and the right side shows the freeform injection molding equivalent. And the numbers are quite, apparent. Taking all elements categories down by somewhere between 70 and 85%. And especially when you look at the environmental impact, when you don't cut metal tools, you do far less impact. And when you only print what you actually need, you also have far less impact on the environment. So, okay, that was the 2,000 feet overview from above. What is, or 10,000 feet, maybe more likely, view of what is freeform injection molding. Let's get down and kick some tires with the processes. This video that I hope will come through as smoothly as it is intended takes you through what the process in steps would look like. Now you have your printers and the resin xMOLD, and now you will print tools. You can do that in whatever format and size and volumes that you want. And the xMOLD resin prints on average 2 to 3 centimeters per hour per full build plane on any of the resin printers that we have at Nexa. And they can then be moved into an ordinary molding space. Here you see our molder putting a sleeve around a printed tool that is a little bit smaller than the mold base we have on the machine. And that is simply just to save mold bases. The spacers act just as an adapter, you could say. Has nothing to do with the molding process as such, just holds a smaller cavity on a large machine. That was a 50-ton Kraus Maffei, by the way. Then the third step is getting to the part, the thing we all want to see and have and bring to market, preferably. With complicated designs like these, xMOLD, the resin has some pretty neat features of being dissolvable. So solubility brings you parts like these, complicated, unlimited undercuts and strange things going on here, gear wheels and other things embedded in this part. But the process always stays the same. The last part is, and I'm just summarizing here the process. The last part of getting the part out of the tool can be done in various ways. We will cover a few of the ranges here. But again, you have your file design through our software, the mold generator software. You will have the opportunity to generate your molding tools. So you go from a design file, step file, STL file, whatever you had, into a mold generator phase where you design your molding tool, and then that molding tool gets printed. You follow the same steps as you would do with any other printed parts. You clean and cure them so they harden up and work as they should. You bring them to, I mean, between 2 and 3, you're literally just moving in to a molding phase with your local mold shop, with your local team in-house or externally, and then it becomes molding. So molding feedstock, molding guidelines, molding quality. Then going from 3 to 4, either you have your part straight out of the tool because you used kind of an A-B kind of mold design, which we will look into shortly, or you use the soluble version, which is literally just with some notes on it. It's a box around a part that is printed that you can then inject, that you can then dissolve. A lot of info is flying across the webinar here, and that's also why this is recorded and will be available to rerun, because I know how it feels to be brain dumping in this this speed. So looking at what is involved in printing, cleaning, and curing, well, you need a printer. We offer a couple resin printers, small, fast, and even bigger and faster. It all depends on what you want. We have an overview later in the webinar. Then the clean and cure, it's either a standalone unit per process, or combination if you go for the desktop versions. Then you have xMOLD, the resin you use for the tool printing, and then you clean it in xClean as a solvent, or IPA for certain types of molding tools. As you just spoke about moving into the molding space, a lot of people have asked us over the years, what unit should I have? I've never been molding, or how big can it be, and how small, and what does it cost, and stuff like that. The quick and dirty answer to that is whatever you have will most likely work, and whatever can get you started depends on your actual use case. So we have teams working all the way from a hand press to a 400, 500, 800 ton unit that they have at their facilities already. So it depends on what your use case, your shot size, your material library you're going to use. It all depends on that. But we are not telling you that you can use that machine or that one. We are actually letting you choose based on real needs. But we do have a good collaboration with a good handful of mold unit suppliers. So should you ever be in need, just reach out to us to have that discussion. So on these ordinary mold units, you kind of use a mud base or an adapter, whatever you want to call it. And in those adapters, you put in the printed tool, and then you inject it. There's a video shortly coming up where it's becoming more apparent what I'm trying to explain here on a slide. But think of it as a modular mud-based system where you can go as close to near net shape in your printed tool, so you don't have to print too much and you don't have to dissolve or demold too much. But that's up to you. The speed comes from the whole thing being an iterative process. Final step in the getting it out of the tool by chemical solubility is having one of our demolding stations. They also come in different sizes depending on your actual need. What they all have in common is that they operate with sodium hydroxide at a 40-50 C temperature. They have some ways of accelerating the demolding process of the parts. And it's difficult to say what is the actual number, but to give you an indication, if you have like a 50 times 50 times 50 millimeter cube with something inside being a part or something you want to mold, that cube will probably dissolve in around 14, 15 hours on an average. So it's a pretty efficient process. This was how the demo center in Palo Alto looked years back when we kind of started showing what does a desktop package look like. So, in reality, this could be your 10 feet tooling and mold manufacturing cell on demand footprint. Not a lot of footprint and pretty easy to combine with other processes, pretty easy to move into facilities you might already have around in your current setups out there. But again, consists of printer, cleaner, curer, mold unit. This one is from Boy Machine. It's a nifty small workhorse. And then to the right, demolding sodium hydroxide. A few steps there. So understanding what freeform injection molding is all about is exactly what Louis also mentioned. If you don't attach this to realities, then it could end up becoming more a theoretical study. So, and it's not. We have a lot of cases out there, and we just recently on our website released 6 of them from different industries. We call them the timelines, and they can be found on nexa3d.com. And I think they're worth just showing one of them here, because they all go through the exact same process as we just showed. You have a part design that you want to bring to life. Then you do a mold design. Then when you've done that mold design, you print the tools to mold the part. And you then molded the tools, then you go to demolding either manually or chemically, depending on that. And then you have a review where you could go, what did this day look like, or what does this week's iterative product development journey look like? And I think those timelines, look them up, because I think they are pretty interesting, because they take place in reality and have a lot of insights on them as well. So hardware, Nexa printers, resin, xMOLD, one resin out of many that you can pour on those resin printers of ours. And I think if you zoom in on what is xMOLD, actually, it's a high temp resin, meaning you can inject beautiful materials from the molding feedstock gallery into it. You can really have a great day in selecting the peaks, the PPAs, the carbon filled PAs, the soft TPEs, the LSRs. It's up to you and your use case. You don't have to hold back on what machinery you use to inject it with, as we covered, and then the solubility. Also, the fact that it's a non-stick resin, meaning if you are shooting TPE into a reusable tool, you will be able to get the TPE out, and it would not stick there like glue or something from a glue gun. It'll actually be manually released from the tool without any release agents or anything put onto the tooling. And then for teams in the medical device space and other, the whole process is biocompatible. So we have a lot of paperwork on that, and quite some of our clients have done their own FTIR testing and cytotox tests on bespoke materials, and they, thank God, came through as expected. But I think that's xMOLD in a nutshell, not holding you back, kind of setting you free, which is the whole intention of freeform injection molding. Just try it out and maybe get there faster, cheaper, and greener. All right, so nothing beats tire kicking in reality. We all know that. So we put together this short insight video of a PepsiCo project we did recently, or some time ago, actually. The tools are printed on a zip printer here in this case, the desktop version. And forgive me for the handhold video. It's me filming and cleaning and curing here. But then they go to, as we spoke about, the cleaning phase in IPA, just looking that everything looks good. And then they go into a little bit of photo shoot here. But then they go into it's not a disco party, but it's an inside look into our UV cure station, the desktop version, to be cured. And then they move into the molding phase. And here you see our molder also showing a little bit about the ductility, the strength, the non-brittle performance criteria of our resin. Here's putting spacers around the mold itself, because you don't want to print, as we mentioned, too much and dissolve too much. So these spacers just align the mold tool that is centered here in the 50-ton mold unit to be injected with PepsiCo's blue HDPE. And in order to save 30 seconds, roughly, I did some edit here. But the thing is, now we move from I wonder how the part looks inside that tool. And there are a few things that are quite evident. One is that you can look that it's full because it's actually there. And another thing about working with these tools, if they are the take-apartable versions, is that you can handle them with power tools and stuff, bolt them up. But here's a really insight or a revelation for anyone in molding. Open up to see the part right there. And I mean, we're still a few hours in on day one here. And this is how it looks like when a part comes straight out of tool, first shot. You can inspect it, you can evaluate what worked, what did not work, what has to change, what can we optimize. And then you can start producing as you see fit. And again, no post-processing, nothing done, just trim the parts after they're out. And a pretty interesting insight from doing this and other projects are actually what are the tools looking like afterwards? What can we use, reuse, and what has to go every time as a sacrificial tool being dissolved? So if you look to the furthest right photo here on this slide, you can see the inside core holding the cap had to go every time because of the undercuts and the threading and stuff like that. But the top part that kind of formed and shaped the outside and surface of the cap could be reused quite many times. I would estimate 40 to 50 times before anything started to see degrading. So suddenly by doing split tools, but kind of also dissolving some of the tool, you now have a way to time optimize, cost optimize, and work around exactly how to bring most value to your product development. That's again a lot of opportunities right there. And I think we did the same thing with the caps for the actual bottle, the normal size bottles, same process, but also same degree of freedom with reusing some, exploring, testing and validating that these will actually work. And with PepsiCo in this case, it did a huge impact on cost and time. We're up in the 90s here if you compare cost to before and time reduction to before. So a lot of value delivered. Another client collaboration that has turned into a partnership as well is with Wilson Sporting Goods. And I don't know if you've seen this before, but I will try to keep it very focused on what it's all about when you do performance parts. And also when you work with materials that we at Nexa had no clue, honestly, what the client is using. But because the xMOLD delivers you that freedom to work with materials that you favor and love, we are not calling you out on what to use and not to use. So with the Wilson case, they already onboarded Freeform Injection Molding almost 3 years ago. And I think back then when we were having all the conversations about what is it compared to regular molding, you could say, one of the comments that at least stand out for me very clearly is that I remember Glenn Mason from Wilson Sporting Goods, who is the director of advanced manufacturing up in Hillsborough. He told me that it's the best decision-making tool he has seen in the molding space. And it's like, that's not too bad a comment. It's not the first one you think about, but actually when you rethink or you dig into that one, it's all about what you can test your way to, what you can measure, what you can change and then remeasure or redo. And here it's actually it's a way for Wilson Sporting Goods to prioritize which projects to move forward, which to back, which not to back, because we all know it costs roughly the same to back the wrong wrong one. The problem is that you will only know later down the product development timeline that it did not work. And at Wilson, they're saying they can bring these conversations with teams, cross-functional teams, designers, material scientists, molders, mold designers. They can actually be in the same meeting room and talk things through, and that accelerates a lot. Actually, the bat that you might have seen online, and you will see on a slide now, is molded using take-apartable tools. So if you look to the right, and actually in the middle of the mold, the steel mold here, you can see there's a drop-in, which is the printed cavity consisting of an A and B side. And the material is still unknown to us. It's a carbon reinforced performance material that holds up for batting and lots of force used. And I think what is interesting with this one is that it's printed on a NXE 400 in xMOLD, and those 6 tools consisting of 12 tool parts were all done in 9 hours. So in 9 hours, you have 6 complete tools, and we were hoping and believing that they would yield a bat each. But what Wilson actually discovered was they could get between 4 and 6 bats per molding tool set. So right there, 9 hours in printing and some cleaning and curing, then you now have the ability to overnight kind of do tools, so you can do around 25 bats next day. And these bats are not simple ones, and neither is the molding equipment. This one here is, I believe, a 418-ton press used to make these bats. And how they look a little bit up closer, on this slide here, you can see not only do they have an awesome look and feel, but also if you look closer, there are some mold texture, in-mold texturing, lettering, and design features, and also design features for how the bat behaves, during actually the game and the rebound and how it flexes and stuff. So there are, a lot of things going on, but all captured in the printed tool you just saw on the other slide. So I mentioned earlier that nothing is post-processed in what you're going to see today, and now we have arrived at one slide with one photo on it where something is post-processed. I think we should, we discussed putting in this slide as a example of how well do we walk the floor of performance materials. So the upper right photo is an example of how a MIM, powder metal molding part has been produced by injecting it into the exact same resin, the xMOLD printed tool that you see on the lower left. So the same tool design, not the same tool because this one dissolves due to the complicated part design, but the same tool can be printed and used for, let's say, 30% carbon filled PPA, unfilled peak or filled peak. We've done that as well. Or, for example, 316L stainless in a catamold feedstock in this case. And then it undergoes just debind, sintering like any other MIM part. And then the post-process thing about this one is that someone in our collaboration network did some electropolishing of it, so it stands out nicely, but it also looked pretty good before, straight out of tool. That's the agility and the versatility you have when you use xMOLD, that you can expand the portfolio of materials and definitely also the designs you can come up with. On this one here, it's also an example of what materials do to certain industry. This is a part we did for German automotive. I think it's 3 years ago. And as you will see on the lower left, it's a part that sits in an xMOLD tool. It sits in a car afterwards in a pretty hot, humid, vibration heavy. It's just a tough space under the hood in a sports race car. And at the number 3 dot there on the photo, it's how it looks after 9 weeks of live testing. You could argue that it's probably not a good idea to send a test client almost white part for them to then put it under a car hood for 9 weeks. It looks a little bit burned and scorched, you could say, but the key thing is it's not broken. So a few things affecting to that, of course. It's injection molded. It happens to be the client's preferred and actually regulatory needed material, a BSF Ultramate 40% glass-filled nylon, and that mix makes it an injection molded part. The difference is that they could test from idea to let's test it in cars in 3 days. So a lot of, again, back to what I mentioned about the Wilson Sporting Goods approach. What do we know? What can we measure? What do we need to change? Do we need to look into other materials or combinations hereof? Whole other industry, whole other size, whole other material gallery, but same process. If you look at this one, it's I know the upper right photo might not be the best for digesting breakfast while watching the webinar, so forgive me for that. But it's all about a design that will make percutaneous screws not stick to your skin. And that's important in some industries, medical device industries and stuff. So if you look at the slide here to the furthest left, there's something that looks like a rendering of the part on a screw. That is the dream scenario. So if that's the dream scenario, then the next photo shows how would the part then look. Next photo then shows what would the mold design look like. Next photo shows the printed tool, printed mold. Do we follow the timeline? You can see a scan of the printed mold. Then they used it to do silicone injection molding. And then last photo on that timeline is a scan of the silicone part. Back again to validation of certain things. Now we can overlay these things from dream to left to actual implementable part to the right. Do we meet the criteria or do we need to go back? The good thing is that this journey took very short time, a couple of days in total, and then you would actually happen to know that kind of insights and you can act on it in real time. And in real time, speaking about what this meant to these guys, they went to animal studies and further data gathering. I think they estimated 10 to 14 times faster than they have ever seen before in such a heavy regulatory driven industry. So super proud and super important that projects like these gets alive or gets reworked and gets another chance. 2 projects here, just to show you how the combination of printed tools and metal and other tools can be worked. Think of freeform injection molding as a way that you can put stuff into the printed tools like metal pins and other things to optimize for surface quality or other things you want to have embedded, insert and overmolded. Or you can also drop printed inserts made out of xMOLD into large steel tools. So you take out the complexities of those tools. Suddenly now sliders, collapsible cores and stuff are not part of your early studies to get to the part that you want to test. This project is an example for an automotive again, where the threading had some things going for it and it needed to be optimized for certain things. And exploring that and designing a way through to find the best optimal outcome to scale up later was accelerated by using freeform injection molding with drop-ins. So to the lower left, you can see a printed core or printed insert put into a larger steel tool where the part itself was kind of molded around in a steel tool. I think it was a Delrin palm material used in this case here. And then later, either, if possible, manually removed or dissolved away, would release the part with the threading, as you see in the middle photo there. And then you can do the testing and you can do the necessary, if needed, corrections, and then you can redo and zoom in on what you actually need and what works. Another version of saying how does that, the reverse version of not dropping in an insert, but dropping in metal. This is a project we did for a team that wanted to explore in the packaging space, how things could work in both feature-wise, but also surface quality-wise and spray channel-wise and stuff. So think of this as a way of embedding, in this case, metal pins into, if you look at the right photo, you can see the xMOLD resin there. If you can embed pins going through the printed tools from various angles, then you can inject the whole thing, pull out the pins, and drop the whole assembly into the sodium hydroxide in one of the demolding stations, and then wait and observe. and then you will have your part. The thing here that is different from using only printed tools is that you can obtain certain things, features, qualities that you might have as part of your industry criteria, and that's a freedom again that you will be given when using freeform injection molding. Speaking of using freeform injection molding, we've been talking a lot about, we have some printers and stuff, and everything is online, you can see, but here it's just a way of saying, how do you get started? Well, I mentioned before that the collaboration with Wilson Sporting Goods has turned into a partnership. So it actually, we're super proud to be able to offer test projects that we can get you started on in case you want to know how would this work in our world. They'll be run out of Wilson Acceleration Center in Hillsborough, using an elite facility and some of the most curious minds we have ever met, and who has 3+ years of experience with freeform injection molding. And they have also these printers available, so it's also a way of testing things out. But our technology solution should not hold you back. We have small, larger, and faster, and there are a lot of specs. They roughly overlap in tech specs. There's a little bit difference in the resolution and stuff, and not much on the speed, but it's actually down to what do you need. We have something that fits your need, I'm pretty sure. That's a discussion we can always have. And then, as mentioned, we did a lot of info sharing today, and hope you had some coffee. I look forward to have a sip of mine over there. But we have a website, nexa3d.com. If you go /digital tooling, then you will zoom in on freeform injection molding. There are tons of information there. And I think we have a lot of good read-ups on processes and products and timelines and stuff. And I think it's just down to absorbing what just was transferred, and then let it sink in. And maybe, I hope, and I would appreciate if someone has maybe already some questions, and I will take a sip of this. Thanks for listening in, and I look forward. You're welcome.
And we already have quite a few questions flowing in. So I'm going to grab a few and hopefully try to put them in an order that makes some sense here. The first is, there's obviously a lot of people who are interested in the process, some more experienced than others. So starting kind of at the front end, what if you've never molded before? What does it take to get started, and how much does it cost?
Okay. A lot of questions in one, but it's also a good combination. I think, what does it take to get started? First thing, there's something you do today you want to change. So you got to be curious. You either met a tough hurdle in your development project. So the curious mindset and the willingness to explore, that's definitely a good starting point. Then in practicalities, on our end, we offer the platforms. That's one thing. But we also offer the mold generator software as a way of saying, if you have a part you want to bring to life, you probably have a part design or today's version of the part design that we can now allow you to transform into a mold design in a guided software tool we call the mold generator software. It's not a magic box where you drop it in and boom, something comes out. It's actually intended to be a guided journey for you to learn how to do other molding mold designs as you grow and as you go. And I think that's one way of taking down the barriers of I've never been molding, because output from that would be a molding tool you now print in xMOLD on some of our printers that you see fit for this. Then from there, getting started, well, we have a lot of collaboration with mold unit suppliers, and we have a good understanding of what a good starting point look like. So the mold unit is normally not included in the packages that we go to market with. But if you look at, if you recall the photo from the 10 feet tool line, which was a zip desktop printer, a zip wash and cure combined unit, and a desktop demolder out to the right to kind of get the part out. That including software, the mold generator software, service, training online, xMOLD resin, what else have I forgotten? That all that stuff, but not the molding unit, because that's either something you have or want to be specific about. That's roughly about $25K USD. for getting you started on a desktop solution. But by that, you literally have a damn good printer that you can pour the print parts resins in that are available and already up and running on the printer register, or you can pour xMOLD in and print tools for molding. But that's I would say that's the getting started, and that's the taking the pain out of have never been molding before. I don't know if I got all of it, but
no, I think you covered it quite well. Okay, so looking at some other questions coming in that seem rather similar. A lot has to do with material compatibility and reusability of the tools. So let's tackle material compatibility first. Is this compatible with materials like TPUs or silicones?
Yeah, it is. That's the short answer. And then depending on whether you want to do we've done lattices, think flexible structures, lattice structures in all kinds of metals, all the way from carbon filled PEEK to medical grade TPEs. So yes, it is. And again, the ability to either enclose everything in something you will dissolve, or have it in a tool where you can actually pull things apart by hand or manually open up and inspect. That's the big difference between, let's say, other printed tool opportunities out there and using xMOLD and the Nexa printers. Yeah.
Absolutely. And then specifically on the silicone, we had someone ask their experience with other 3D printed resins are that it seems to, for lack of a better word, poison the platinum catalyst silicones and prevent curing. Do you see that as an issue with this resin?
I mean, silicone is a big space, and there are quite many specifications to various industries and various use cases. But we have a lot of clients using silicones as their library of materials. What we have seen is that the biocompatibility that is built into the chemistry of the resins and the whole process does not pollute any of the materials that are then captured or handled in these processes and steps. On the curing, there will be opportunities to post-cure. There will be opportunities to release the part in different ways, but natively, the parts will not stick. They will not be contaminated by the tool resins, and it will again be down to the design of that specific part or that combination of parts you will have. Maybe you're using, like we saw in the presentation here, overmolding on top of things. That'll be down to the use case, how well first out of tool will look. But technology-wise, nothing is holding you back from exploring quite many combinations here, also with silicones, and also at the other end of the scale with the high performance materials.
Great. All right. This is a great question. So they were wanting to know if a 3D printed tool with xMOLD would be a good solution to produce parts in medium to low volume. So for example, 200 to 800 units.
I mean, just here on a question level, it's difficult to judge, but we peeked into what we call hybrid tooling. Hybrid tooling is a way of also getting to scale. You saw the PepsiCo large project, the overcap, or the magic cap or whatever, from actually featured in the second Back to the Future movie as part of that diner scene there. Had to go and rewatch it, but you saw that one being reused, let's say 50 times. How many times it can be used with a certain part is not known before the part is designed for something. It could be designed for the fact I want it now. Then you will just do a one block to solve everything. You could also design it for, I want to explore how I can go to scale the 200, the 5, the 800s. And then if you imagine that you can reuse some of the tools, you could also make some of the tools a steel side or aluminum side, and the other face or the complicated side of the part tool could be printed. So you can get to scale from different points of view. The overall go-to way of thinking about freeform injection molding is that you can get to what needs to scale faster. You could often and possibly go to quite some volumes with freeform injection molding, but it's intended to get you to the knowledge that what would you then be doing in order to scale. But on that note, there's a case on our website on the timelines where we did the a COVID project with a adapter for a full face snorkel mask and a HEPA filter. And in that one, you will see a tool that we printed in xMOLD, and where we actually did in that tool that is shown in the timeline there, we did 400 parts before we printed a new tool to do more parts. More parts were needed back in, when was it? I luckily forgot, but it feels like long ago. But when it was at the onset, there was only a need for everything in the personal protection equipment industry, and that's where we did 400 in one printed tool. So yeah, you can get to a certain amount of scale, but you have the opportunity to combine technologies to get there if FIM cannot get you there alone.
Okay. Another great question regarding kind of technology comparisons. How does freeform injection molding compare to traditional urethane casting?
I mean, it's often about, are you pouring stuff in? Are you squeezing stuff in using molding guidelines? And I think it's can you pack the material? Can you hold the pack pressure? Can you test the part for structural rigidity and life performance afterwards? So in that sense, it's the amount of materials you can use in FIM is quite vast, and the way you can handle it compared to regular injection molding is similar. So and then again, when you move from working with your design and your iterations in freeform injection molding, imagine how much stuff, if you recall again the PepsiCo video from our mold shop, if you look at how those vents and gates were placed, when you move from working with freeform injection molding in digital tooling, you can translate that knowledge from, where did we put that? Is that a good cosmetic service to put a gate on? Do we need to vent it differently? All of that information will be carried forward to already from your molding team at an early stage. So there are quite many differences in what you capture as you go, because you don't kind of change technology or process technology in the midst of things. I don't know.
And I have quite a bit of experience with urethane casting, so I'll add to it or provide kind of a succinct distinction, and that really is, you're going from, from a material standpoint, molding in, production grade thermoplastics, everything from your very common, ABSs and things like that, to some really high performance plastics like carbon filled PEC.
Yeah.
And this material is compatible with that. The second thing is the time. So if you're moving fast with urethane casting, you're probably looking at a 5 to 7 day lead time from your first printed part to the silicone tool to your first casting that's cleaned up and everything like that. Whereas you could have a part same day or next day in your intended plastic with freeform injection molding. So urethane casting has probably the advantage of size. Obviously, there's not really a huge limit to tools if you're very, very experienced. However, with the particular printers like the Zip Pro or the NXE 400 Pro, those have sizable build volumes that I think are going to accommodate the majority of tools or part geometries. So that is of consideration there.
Good point, yeah.
Next thing that I want to cover, I know we're coming close to the end of time here. It really has to do with the, getting started. What molding presses do you recommend? How do you deal with a learning curve? And so I would, want to cover that when it comes to the getting started and thinking about molding. Karsten did a great job of highlighting that this is widely compatible with a small desktop press, as it is with the 480-ton press that you saw at Wilson. in that example, and others as well. So it's widely compatible from that standpoint. As you're getting started, we have a lot of experience with the smaller desktop units and kind of creating that 10-foot factory, if you will, that Karsten showed. But even, there are some smaller options as well, as if you're looking at that. Karsten, I believe we've even tested it with like a manual press before, haven't we?
Oh yeah, I mean, there's in the photo in the slide deck, there's one from Holy Press or Holly Press, and if that gets you going, that it works. It's very manual. You can put the printed tool at the bottom in a fixture, and then you can by hand press kind of control it. There's also one from APSX and Kubikara's team there. It's a much more industrial desktop looking unit, but it brings you the ability to work with a wide range of materials. And then you go to the boy machines where you have, screw and barrel, and you can have shot sizes that are exactly as I mentioned, accommodating what you actually need, and could be future proof if you need more a little bit later once you get the hang of printed tools and molding yourself. So don't let anyone hold back on is this available? What does it cost? It's also a supply chain you can break down many places. So if you don't have a mold unit in-house, send it to your molding team wherever they are, and they can mold it, send it back to you. You can demold it. It's very
and you can
it's very logistic friendly.
You can also consult with someone like our partnership with Wilson, who can kind of help you get started with that process, validate it as a proof of concept before you look at adopting it in-house as well. Okay,
Definitely.
we're right at time. I'm gonna ask one more question before we finish up. And that is, I think, a really interesting one. That is, how common is it to make a multi-cavity tool with xMOLD?
How hard is it, or
how hard or how common is it?
oh, okay.
Probably can address that.
I mean, I think the short answer to that: why would you do a multi-cavity tool unless you know you want a lot of the parts at scale here and now? That's why you do multi-cavity. If you think about proofing design materials or both in an iterative process, we've done multi-cavity a few times, but it does not lend itself to a lot of advantages, because you have to design spruce runners and different gauge systems and stuff. But with a single cavity, and even sacrificial, if you want to go for the safest route, the quickest route to part in hand that you can look at and measure, it's a single cavity. We've done 2, 4, 6 cavity tools with small things and larger things, but we don't see an advantage, especially because if you look at the printers we offer, the speed they can deliver, it actually ends up being your mold press being a bottleneck when you can produce a molding tool. If you fill the build plane on a bigger one with a couple of inches tall molding tools, I think the cycle time per part is 15 seconds or something like that in some of our cases. So suddenly you have tools at hand, and they, by the way, don't have to be the same design. They can be maybe not 120 different designs, but you can test your way through. So short answer, not that short anyway, but it does not lend itself to a lot of advantages to try early on and think multi-cavity.
Thank you so much for joining us. Have a great day and a great weekend upcoming.
Thanks all.
And we'll look forward to speaking with you soon again about freeform injection molding.